in this question, it is given that n blocks of length L are stacked on top of each other at edge of a table as shown in the figure. And here there are 4 blocks, okay, one over the other. We have to find what is the largest distance between the rightmost point of the top block and the table itself. This distance they are asking, that also the maximum possible one. Fine. And we have to see how it behaves for very large values of n, as n tends to infinity as well. So I'll try to solve this question for n is equal to infinity first, or random n value. Then I'll plug in my value of n is equal to 4 to get result for n is equal to 4. A logic to solve this question is very basic. You have a rod, at center of mass mg will be acting. The moment center of mass crosses the table, it will flip over because of the torque due to mg. This is the basic logic that we are going to use. So what is the maximum distance I can keep outside the table? The center of mass which is there should just come above the table. If it crosses this, it will flip. If it is before this, it's safe, but that's not the maximum one. So exactly above the table is the safest position that we can keep. And we'll use this logic now for a n block system. If you have n blocks, these are n blocks. In that, I'm making this n minus 1 blocks as one system and this one block as a separate one. Fine. So I can claim by using the previous logic that center of mass of these n minus 1 blocks in the orange dotted line should lie above point A. Otherwise, if center of mass is somewhere here, it flips. If center of mass is here, it's not the maximum distance that we can achieve. So center of mass of this system is somewhere above A. And for the full system combined, including the bottom one, I can tell that it should be above B. Okay, this is center of mass of all n blocks combined is above point B. Center of mass of all n minus 1 blocks in the orange dotted line is above point A. Now, by using this logic, I can keep n minus 1 m mass at A. Actually, it has to be somewhere above A, but I'm worried only about the horizontal distance. I'm keeping it at A. Now, this x is the overhang of this block. Fine. If you have n blocks, fine. Now, here, this last block will have center of mass here of that one alone. Now, for this combined system, center of mass is at B. So, if center of mass is at B, about B, mass movement should be 0 of the system because this is center of mass of the system. So, the same logic will use this n minus 1 mass, n minus 1 m mass is at a distance x. And where is this m mass? What is this length? L by 2 minus x. So, we'll equate the mass moments n minus 1 m mass into what is the distance from center of mass of the system? It's x. So, I substituted x, mass into this distance. And this m mass is at what distance? What is this length? This one minus this one, which is L by 2 minus x. So, same thing we have substituted here. So, we got x is equal to L by 2, but with some simple rearrangement of this equation. After getting that, this is the overhang that you'll have for the nth block if you have n blocks, the bottommost one. Now, if you don't have anything, let's say the first one, what should be the overhang? n1, so L by 2. For this, n2, so this one will be L by 4, substitute 2 here. Next one, L by 6 and so on, L by 8 and L by 12. This series continues L by 12. Now, if you have 4, I can just add this L by 2 plus L by 4 plus L by 6 plus L by 8. So, if I do that addition, you got 25 L by 24. So, that is the maximum horizontal distance we can keep of the rightmost point of the top block. Now, if n tends to infinity, we can use this Euler-Mascheroni constant where gamma is 0.57721. Okay, this is named like that. If you want a detailed proof, you can search for it. This is the name of the constant. So, for a very large values of n, we can get maximum overhang distance as this one. Okay. So, to get this one, we have just rearranged this because actually we have summation of 1 by I to infinity. We have summation of 1 by I, 1 to n. Here 1 to infinity. I just took this ln n towards right side. So gamma plus ln n is summation of 1 by I. Usually summation of 1 by I diverges. This one is valid if n is some 1000, 2000. You can get almost a close enough result here. Okay.